In this video, we're going to kind of refresh your memory on a topic that we covered last session when we did equations in quadratics, and it's solving quadratics. Now, this is a National 5 topic we covered, but it becomes quite important at higher, and it's something we have to make sure is fresh in our memory and we're able to do. So, we're going to do a quick revise with this. Now, solving a quadratic is fairly straightforward. You just have to remember the key steps to doing it. Now, to solve any quadratic, the first thing you have to do is set the quadratic equal to 0. Now, regardless of what format the equation is written in, what you have to do is you have to end up with something of the same format. Now, it always has to be ax squared plus bx plus c equal to 0. It has to be that format. So the whole quadratic on the left equals 0. What you can then do is factorise the left-hand side of the equation. Now, that's the way we're going to approach it here. You could also use the quadratic formula, but that's in the next video. So have a look at that in that video there. We're going to look at just factorising and how we can use that to solve it in this one. What we then do is take this factorised version of the equation and find the values of x which solve it and allow us to get an answer for it. Now, a topic like this, quickest and easiest way to show you what I'm going on about is with a few examples. So here you go. First one, solve x squared plus 8x plus 12 equal to 0. Now, first thing we said we want to do is set the quadratic equal to 0 in the form ax squared plus bx plus c equals 0. I've already done that in this case. What I now need to do is factorise the left-hand side. When you're factorising, the coefficient of x squared is 1, so what that means is I'm looking for two numbers that add to give me the middle and multiply to give me the end. If coefficient of x squared is different, that adds an extra step in, and we'll show you that in a second. I want two numbers that add to give me 8 and multiply to give me 12 in this case. Well, the only two numbers that give you that are 6 and 2. So I've got x plus 6, x plus 2 equal to 0. So I've got x plus 6 times x plus 2 equals 0. Now, that means either of these two could be 0. So I get my two solutions by taking the x plus 6 equal to 0 from that bracket, or taking this bracket and saying x plus 2 equals 0. It could be either, we're not restricted in this case. So if x plus 6 is equal to 0, I know x is equal to negative 6. And if x plus 2 is equal to 0, I know that x is equal to negative 2. And there you go, I've got my solutions to my quadratic. Alright, sometimes it's fairly straightforward. Like I say, the thing which could add a level of complexity is the coefficient of x squared being something other than 1. Like in this example here. So I've got 6x squared plus x minus 15 equals 0. So I want to solve this and get a solution to this equation. Now, what I'm going to do is I'm going to look at this side. Now, if this was equal to 1, great. I could just straight away factorise it by looking at two numbers that add to give you this and multiply to give you that. But in this case, it's not. My coefficient of x squared is 6. So what I need to do is up the ante and do a few more steps. My first step is to take 6 and 15 and multiply them together. 6 times 15 is 90. Now what I'm going to do is I'm going to look for pairs of factors of 90. Now 90's got a lot of pairs of factors in it. If this was a smaller number like 6, you could list them all and then get an answer. But what I'm looking for is a pair of factors that give me 90. Now, key thing to look at this stage is the signs. Remember, when they multiply together they give you this, and when they add together they give you this. So they multiply to give me a negative, which means one of the two numbers is negative, but because they add to give me a positive, I know that the bigger of the two numbers is going to be the positive one. So I know the bigger of my two numbers is going to be positive. So the pair of factors that multiply to give me 90, add to give me 1, that would be 9 and 10, but remember one of them is negative, so that's the 9. Negative 9 plus 10 gives you the 1. What you then do is split your quadratic. So in this case, what I'd say is 6x squared, take away 9x, plus 10x, minus 15, equals 0. Remember, if we simplify this bit in the middle, minus 9x plus 10x just gives me the x. Great. Then, follow the steps we talked about in class. Split it down the middle, common factor on both sides. So common factor on this side is 3x. So I get 3x, bracket 2x, take away 3. Common factor on this side is 5, so it's plus 5, bracket 2x minus 3, that equals 0. Now look at this. They've both got the same bracket here, so that is one part of my solution, 2x minus 3. The second part comes when we cross those out and we're left with 3x plus 5, which gives me my second bracket. And that equals 0. And again, same step at this point as the last one. This bracket gives me an answer. This bracket gives me an answer. We don't know which one specifically it might be looking for. If it gave us a specific range of x's, we could, but it doesn't in this case. So I get 2x minus 3 equals 0, and 3x plus 5 equals 0. So 2x minus 3 equals 0, 2x is equal to 3, and now for this one, x is equal to 3 over 2, and this one here, 3x plus 5 is 0, so 3x is negative 5, x is negative 5 over 3. So there you go, I've got my two answers there for this one. Now both of these were written in the form we want, the ax squared plus bx plus c. Sometimes it's not, and we have to start by getting it to that form. So this example here says solve 2x bracket x minus 9 equals negative 28. For this one, we have to get it in that form to begin with. So to start with there, multiply out these brackets and then shift this over here. Remember, ultimately, we want equal to 0. So multiply out this bracket, you get 2x squared plus 18x, and then we shift this over, plus 28. And that equals 0. So we've got it now in the form we want. Now we want to factorise. Now remember the three different types of factorising we talked about. Common factor, difference of two squares, and trinomial. We can combine these three, because if you look at this, there's a common factor of 2 everywhere. So I can take that out and have 2 bracket x squared plus 9x plus 14 equals 0. And this is going to make my life a little bit easier purely because it's 2 times something is 0. Well, 2 can't be 0, so I can just focus on that. So I can just look at x squared plus 9x plus 14 equals 0. And factorise it the same way. We're looking for two numbers that add to give me the middle and multiply to give me the end. So two numbers that multiply to give you 14 and add to give you 9. There's only one pair, 7 and 2. So I've got x plus 7 and x plus 2 equals 0. Then the same steps again. There's one solution, there's second solution. So first solution, x plus 7 is 0. Second solution comes from x plus 2 equals 0 as well. So this one gives you x equals negative 7. This one gives you x equals negative 2. Bosh, you've done it. That's your two answers there. Remember these steps, and it's always the same. First, get it in the format we want, so quadratic equal to 0. Second one, we then factorise it in this case. We could use the quadratic formula if it was more complex, but we just looked at factorising here. And the third one is do this stage here at the end, remembering that you can get multiple solutions and which ones you want. Unless it gives you a range of values, you have to take all of them into account.